All right, so this question says, given triangle ABC as shown, one of the 5 segments of, A, B, B, C, C, D, D, A, B, they're selected at random. And so a second segment is selected from those remaining 4. And so we're looking for the probability expressed as a fraction that the segments picked in order have lengths in the ratio 4/3 or alternatively 3/2. So, first let's just look at how many ways can we get this ratio 4/3 or 3/2. And the way, I first want to look at this is, we have 3 different side lengths here. We have 18, 27, and 36. And this makes our lives so much easier. If we look at 27, the relationship between, let's just look at actually 36 and 18. That's a 2-to-1 ratio, which is not any of these possibilities. So we don't have to worry about that. Let's just look at the ratio 27 to 18 and 36 to 27. So those are the only other, relationships. Well, at 27 to 18, if we divide both of these by 9, we get that this is a 3-to-2 ratio. And then if you were to divide 36 and 27 each by 9, you'd get a 4-to-3 ratio. So this works out because these are exactly the ratios we're looking for. So we're looking for the probability that the segments picked have lengths in the ratio 4/3 or 3/2. So let's just look at, what does it mean when it says we're looking for the probability that the segments picked in order have, lengths in the ratio 4/3. So basically, the only way we can get a ratio of 4/3 is if someone picks a 36 and a 27 in that order. So the probability that that happens is just the amount of ways to pick a 36 or a 27 over just the total ways to pick 2 sides. Now we can do the same thing with a 3/2 ratio. It's just, the probability of that the segments picked have lengths in that ratio is just the number of ways you can first pick 27 and then 18 all over the total ways you can just pick 2 line segments. So let's just look at first the total number of ways you can pick 2 line segments, okay? So it says first you pick from those first 5 segments, and then a second segment is picked from the remaining 4. So we have 5 options for that first segment, and then 4 options for that second segment. So the total number of ways we can pick 2 segments is going to be 5 times 4, or 20 total ways. Now, how many ways can you, get a ratio of 4/3? So meaning you pick a 36 first and then a 27. Well, there's only one way to pick a 36, but there's 3 different ways to pick a 27, meaning there's 1 times 3, or 3 ways to first pick a 36 or a 27, right? You could either pick 36 and this 27, or 36 and that 27, or 36 and that 27. So that's 3 ways. Same thing for the ratio 3/2. There's 3 different ways to pick that 27, but only 1 way to pick that 18. So these right here, those are your 3 possible ways to pick 2 sides with the ratio 3/2 in that order. So this ends up being 6/20, which we can divide by 2 to get 3/10. So, the probability that the segments picked in order have lengths in, these 2 ratios is 3/10.